Last episode, we hardened the model with monotonic constraints. Wait, no, that's later. Here's where we actually are. Back in Epo 2, we built the house, the phishing URL detector, Seed42, PRIUC 0952. Every episode since has tuned it, rebalanced it, threshold swept it. Today, an analyst sits at the SOCI console at 2 a.m. and it fires. One URL, score 0.96, flagged as phishing. And the analyst asks the only question that matters at 2 a.m. Why? The score is a verdict with no testimony. A 0.96 doesn't tell you whether to block, escalate, or wave it through. Today, we make the model testify. We take that one alert and run SHAP on it, and the black box turns into a sentence. Flagged because the URL stacks suspicious subdomains and hides an @ symbol. That sentence is the entire difference between an alert that gets triaged and an alert that gets tuned out. First, the misconception that gets models thrown out of SOCIs. A high score is enough. If it says 0.96, just block it. It isn't enough, and here's why operationally. An analyst can't action a number. A block list push, a user lockout, a ticket to the email team. Every one of those costs a human something, and no human signs off on the model said so. They need a reason they can defend. A bare score is untriageable. The whole game today is converting 0.96 into something a tier 1 analyst can read in 2 seconds and act on. Second misconception, feature importance already tells me why. No, global importance tells you what the model cares about on average. Across the whole test set, it says subdomain count matters a lot generally. But this alert isn't the average. Maybe this URL has perfectly normal subdomains and fired for a totally different reason. Global importance is a population statistic. Triage is a single case. You need a local explanation. Why this URL, this score right now? That's the leap from a bar chart of averages to a per alert breakdown. So what is SHAP actually doing? SHAP works in the model's raw margin. Log odds, the number before the sigmoid squashes it to a probability. Picture that margin as a budget that starts at one fixed number, the base value, the margin the model would give with no information, the average over the training data. For our phishing model, that base is about 1.8. Then every feature is a contributor who either pushes the margin up toward phishing or pulls it down toward benign, and SHAP hands each feature its exact share of the move. The misconception it kills, SHAP guesses which feature mattered. It doesn't guess. These are Shapley values from game theory, the unique fair split of the prediction across features. They add up. Base 1.8 plus every push and pull lands on a margin of about 3.18, and the sigmoid turns that into the 0.96 you saw. The explanation isn't a story we tell about the model. It's arithmetic the model is forced to show. Now the shape that makes it readable, the waterfall. Start at the base 1.8 on the left, then stack the contributions biggest first. Subdomain count shoves it up, bus on bounds at 1098. This URL stacks an unusual pile of subdomains. The PayPal secure login.ru move has that symbol adds another zode67. There's an @ buried in the URL, the classic redirect trick. Num dots pal 0.2 entropy pal 0.12, brand in subdomain 0.11, small upward nudges, and one feature pushes back, URL length at 0.64. This URL is actually short, mildly arguing it's legit. Sum it all on top of the base and the margin lands near 3.18. Sigmoid 0.96, read top to bottom, and you have your sentence, flagged for stacked subdomains and a hidden ATE despite a short URL. Watch what the green bar that points down does for trust. URL length at 0.64 is the model saying, I consider the evidence that this is benign, and here's exactly how much I weighed it. A model that only ever shows you reasons to block looks like a hammer. A model that shows you that 0.64 of counter evidence and still lands at 0.96 looks like a colleague who did the work. The misconception here, explanations are just the model justifying itself. No, the honest ones show the case against the verdict too, and that's precisely what lets an analyst trust the verdict. Here's the triage payoff, concretely. Two alerts both score 0.96. Alert A's waterfall is dominated by subdomain count and has at symbol stacked subdomains a hidden at. Alert B's 0.96 comes almost entirely from numdots because it's a legitimately dotted tracking URL. Same score, completely different story. Alert A is a confident block. Alert B is let me look closer, dotted isn't malicious. The score couldn't separate them, the waterfall does. That's why SHAP isn't a nice to have dashboard, it's the routing logic between autoblock and human look. One myth to retire before we code: SHAP retrains or changes the model. It doesn't touch the model at all. We trained the EPS02 detector once, froze it, and SHAP is a read-only lens we hold up to it afterward. It's an X-ray, not surgery. Same weights, same dope N952 PR AIUC, every score identical to before, which means you can bolt it onto a model that's already shipping today without retraining a thing. Now let's pull one real true positive out of the test set and X-ray it. Open 12 SHAP triage.py, about 60 lines. We rebuild the exact EPO2 house, make classification seat 42, the same 12 lexical host features, the same scale pause weight, so this model is byte identical to the one we've carried all series, PR AIOC 0.952. Then we do the new thing, pick one high scoring true positive from the test set, run a SHAP.tree explainer on it, and print plus plot its waterfall. First the frozen dataset and split. Make classification with random state 42, weights 0.8, 0.2 to keep phishing the minority. Then we rename the 12 columns to the real phishing features, URL length, numdots, has HTTPS, subdomain count, entropy, has its symbol, brand and subdomain, and the rest. Same seed, same train test split, so the test set is the one we've used since EPO2. Nothing here is new, it's the recurring house, reconstructed deterministically. Train the detector, also unchanged. XGB classifier, scale PO's weight set to the benign phishing ratio, so the rare class gets its fair gradient, max depth 4, eta mother phone, and estimators 300. We score the test set, we print PR IOC, and it reads 0.952, the house number. This block exists only to reproduce the model we're about to explain. SHAP needs the trained booster, not a fresh one. Now pick the alert. We score the whole test set, masked to the true positives, actually phishing URLs the model caught, and grab the one whose probability is closest to our headline 0.96. We pull its row out as alert, record its index as URL 7421, and that single sample is the entire subject of the rest of the file. One alert the way an analyst sees one alert. The explanation itself, 3 lines that do all the work. Explainer, SHAP.tree explainer model, builds the read-only lens over the frozen booster. SV or show, explainer alert, computes the Shapley values for our one row. The explainer expected value is the base, about 1.8 in log odds. SV.values are the per feature pushes that sum on top of it. We print the top 3 by absolute contribution. Subdomain count plus 0.1098, has at symbol plus 0.67, URL length 0.64, the exact headline, no model surgery, tree explainer just reads the trees. Finally, we render the hero, SHAP plots at waterfall SV, draws the base to 3.18 log odds cascade, red bars pushing right toward phishing, green bars pushing left toward benign, features sorted by magnitude. We assert that base plus and 7 values, sum equals the model's raw margin for the alert. Additivity is a hard check, not a hope, and the sigmoid of that margin is 0.96. So the figure, the terminal, and the headline are guaranteed to be the same numbers. That's triage. A score becomes a sentence, and a sentence becomes a decision. We've now got a detector that's balanced, honest about PRAUC, threshold aware, and as of today, explainable per alert. But there's still one operational knob we keep hand waving. How many of these alerts can the SOC actually handle in a day, and what recall does that budget buy us? Next episode, SE's 13, the false positive budget. We sweep the decision threshold to turn a fixed number of alerts per day into the recall you can really ship. The most important knob in the whole pipeline. See you there.